Hello everyone, welcome to my YouTube channel Data Partnership. So this video is continuation of my rainfall series, basically rainfall analysis series, where I am using XARRAY, which is a Python library, right? So in my previous videos, I showed you how to extract rainfall data for particular locations, right? For multiple locations. So, and we have what we did is we imported Python libraries. We loaded the rainfall netCDF file, and we have multiple lat long, and we converted that into point data, and we created a data frame, and then we created a time series for particular locations, right? And we have plotted, and finally we exported it into CSV file, which is a time series. That's fine. So now today video is basically for the uh, how we will plot. We have two types of. Now we will. I have a shape file. I want to extract data for my region, means whatever it's a district catchment, whatever. So I'm using one of the district shape file, no, one of the state shape file as a sample. So we have two cases. One is annual total per grid, basically map of rainfall distribution, because this our data is especially distributed. We have it's a gridded file, raster file, right? So how some rainfall across time dimension, and each grid means what will be the result. Each grid cell has one value, annual total rainfall, means I'm just as an example I'm doing total rainfall, how much rainfall happened in 1 year, right? Because since I'm using only 1 year data, and use cases produce a special map. Its example is suppose grid 1 have this 1000 for January to December, or maybe other values also, right? Grid B something, grid C is like that. So when we plot, I will get a map. Basically, grid A means it's a accumulation, means total rainfall from January to December. So we will have a one grid. Similarly, for total daily rainfall for whole region, means it will give us a time series. Like we have grids, right? Each day has one value, total rainfall across the region. So produce a time series plot where x-axis and is the date, and y-axis in the is the rainfall. Means first January we have first 150, second is 200. Means it will be sum of all days, not the grid, right? So let's do it in Python. How to do that using XARRAY. So I have already this imported these files, and this we have all the time we are doing is those who are watching first time, so please refer my previous video, right? So what I have done, so now what I will do is we have loaded netcdf file. Now we will load the shape file. So what I will do is gdf, because since it's a I am using geopanda, so gpd dot read file, and it's a state ka, right? Dot shp, run it. So well, so most important thing is that if shape file has no CRS, so we have to assign it manually, right? Because we have given this we our rainfall raster is already, we have given the CRS. So now what we will do is if gdf dot crs is none, right? And what we will do is gdf equal to gdf dot set, we will set the CRS similar ESG 4326, right? Like this. Now we will assign it. Make sure CRS matches with the, so GDF equal to XARRAY dot to CRS coordinate reference system. Which one? EPSG 4326. Correct. Run it, and now you can print GDF dot CRS. You can see. So we have the same coordinate system whatever we have assigned to the raster, and similarly for GDF. This is the important step. Now what we will do is we have this, if suppose we have plotted GDF dot, let's see how it comes. So we have this state boundary, because we have seen my if you see my video 2 or video 1 2 3, I have shown that we have this netCDF file belongs to whole country, for whole India. So now what we are trying is we are trying to plot for this one of the state in India, Karnataka, just sample, right? So how we will clip that? So let's do it. Rain clip equal to rain. First we have this is rain, right? Rain underscore clipped, rain underscore clip, so rain dot rio dot clip gdf dot geometry, geometry dot apply, gdf dot crs. Run this. So this is the code we have to write, and now we will calculate the daily total. So let's do it here. The next daily total equal to rain clip. Now we have this one dot sum of which are the dimensions are, we know the latitude and longitude, right? Worked. Then suppose we, yeah. So now what we are going to do is, now we are trying to plot it how it looks like, or what we will do is daily total means dot daily total. It's a very important video, I would say, for those who are working, just beginner or using the rainfall data directly. So it will give you some background data frame, right? Reset, run. So it is working. So now daily total to CSV daily CSV. Just I want to show you that how it looks like, right? So daily total CSV. So where is rainfall daily total, this one. So if you see how it is coming, so it means we have days and we have rainfall. So you can see we should have 365 values, right? So we have 365 values. It's a means every day this it took it what it did is It is total rainfall for particular one day based on the basically it's a means for each latitude longitude. What it did is for particular day it's sum for all the latitude longitude, and then uh, it gives you the total rainfall for one day, means for every day, for each day, right? So let's plot it. So how it looks like the PLT dot figure. Maybe I will just copy it from here, right? So I want to save the time. Paste something differently. PLT dot figure, PLT dot figure. Right click side it, this one. Just removing, you can put it. So attention, right? So what I'm going to do is daily and total plot. Suppose just I want to zoom. So it will be like this, right? So how it looks like is like this. So but it is not giving me the proper information. So what I will do is I will just put it, I will do it in a better way, right? Daily total. So total rainfall, right? Grid also, then multi dot. So let's do it. So it will be like this. I will run it again because it's not coming properly, right? That's I'm telling you, this something is daily total. So what I will do is something is wrong here. So daily total, rain clipped is daily total is rain clipped dot sum, done. Daily total data frame. It is giving this error, permission denied. Okay, I have clicked on it. That's why it's happening. Okay, so just run it, and this will be not convinced with this. This should not come like this way. Right? Hmm, let's see this daily. Let's go total times. Yeah, now it's coming. Right. So actually it confused. So now suppose we daily if we plot this daily total and total rainfall, so you can see how it is coming, right? So you have plotted it and you also exported it into CSV file. So this is one case. The another case is that how to now the grid total. This is for our this area, right? It is just it will be a time series. So now if suppose grid total equal to rain clipped, input will be the same dot sum. Now our dimension will be time. Earlier what was there? Latitude, longitude. So grid total equal to, this is grid total dot to data frame dot reset index. I'm just so that you can check it on just for the comparison, right? Dot to CSV test 1234 dot CSV, done, right? So you can say we have this one, right? Yeah, so it will be, so you can see here. So in my previous daily total was like this, means we have date and we have rainfall. So now this one is we have grids and we have rainfall. So it is specially distributed. You can see that is different. So it is more than 365, right? So we have number of cells, right? So it what it did is it total the number of cells, means in a particular cell what will be the uh, total rainfall for whole year. So similarly for the other grid cells, so it worked at a grid by grid, right? So how to plot it? So now what we will do is fake ax equal to plt dot subplots, right? Fix size equal to 10 7, and grid total dot plot ax ax cmap whatever you want, but I use, and add color bar equal to true XARRAY dot boundary dot plot ax equal to ax, color is black, equal to 1, let's say, right? And ax dot subtitle, you can change title as well, right? Total rainfall, total rainfall per grid. Dot. So let's go. Okay. So grid dot total plot ax equal to ax, enough is blue, red color bars. It's fine, it's wrong here. Okay, so let's review it again. Figure is it's approach XL is 10 7. Total plot similar lows. What if I remove it? Let's see. It's coming like this. Maybe this was the region. Yeah, you can see. So because it confused because I have mentioned I just want to directly this plotting this. So what I'm doing it is a data frame. So that's why it is happening. I will look into it why it is why it, so because it confused whether it is so this one or it is so this one. Both are different, right? So this is you can see now we have specially distributed uh, thing. Yeah. So it means that for each grid cell we have a means a total rainfall. So this is what I wanted to show you for a particular region, and you can change the dimension here if you want to make more beautiful maps. Then you can accordingly change the dimension also. So that's it, guys. I think it is helpful, and because you can see it's very important, I would say. So what we learned today is that we have an HDF file, we have a shape file, how to click for that particular area, how to create a time series, this one, and what how to create a specially distributed map and how and as well as in the CSV file. So this is what I wanted to show, and next will be more means advanced to this level, and we will see how to what we can do further, right? Stay with me, and please subscribe my channel, and this is whatever I'm learning. I'm just trying to show you so that you can also learn. You can maybe you can do better than me, because I'm learning, and whatever I'm learning I'm just creating a video for that to help you. Thank you.